Hey guys, so today we're going to be talking about radians versus degrees. So first of all, we need to talk about what are radians. Well, let's look at this link for a second. So I'm going to wait until it replays, but we have this line, and if we drag it along another radius, it becomes the arc of this circle. And it's still equal to 1 radian. Now you're probably wondering, okay, well, what's a radian? Well, 1 radian is like if we took the radius of the circle and made it the arc. So the arc now is 1 radian, so that means the angle is 1 radian as well. Alright? So let's draw this on our circle. So we have from the center of the circle to the edge is called the radius, or r. And then we have another angle here, or not angle, segment, and that's a radius as well. Because the radius is equal all throughout the circle. Alright? And then we take this and we put it along our circle, and this is our radius as well. It's just a curved radius. So now that we have this, we can say that our angle is 1 radian. Okay? So now let's look at what I have over here. So I have circumference. Well, we know that a circumference of a circle is 2 pi r. So 2 times pi times the radius. Well, now I need to figure out, well, how many arcs are there in one circle? We can do this by, just about drawing it on our edges. So we have 1, 2, 3, 4, 5, 6, and with a little bit left over. Now this isn't exact because I'm drawing it, but to get the point across. So that means we have the number of arcs to be 2 pi. Alright? So because we know that there are 2 pi arcs, we can say that one full rotation is 2 pi radians. Okay? And then this is where we can get our formula for converting between radians and degrees. So one full rotation is also equal to, well, how much is a full rotation in a circle? Well, it's going to be 360 degrees. A circle, if we went all the way around a line, that would be 360 degrees. Alright, so we can set them equal to each other. And we can use this to find other relationships. So our first relationship that we can say that we've already kind of figured out is 2 pi radians, and is going to be equal to 360 degrees. Well, that is one full rotation, as we said. Our next relationship that we can say is if we divided both of these by 2, well, we would get pi radians is equal to 180 degrees, and that would be a half rotation. Alright, and then, well, what if we then divided this by 4? So then we would have pi over 2 radians is equal to 90 degrees, which is going to be a quarter rotation, or, a right angle. Okay, so that's the basics of radians. So say we wanted to convert from radians to degrees. Well, for that, all we have to do is multiply our radians by 180 over pi. That is all we have to do. Okay, so let's look at our first example. So 2 radians. So I'm going to take 2 and we're going to multiply it by 180 over pi. And then we're going to get 114.6 degrees. Okay? So that's one way radians can be given to you. Another way radians can be given to you is with pi over 3, or negative 17 pi over 9. So those are two ways that radians can be given to you. So now that we're given pi over 3, we're going to do the exact same process. So we're just going to multiply it by 180 over pi, and then we'll get 60 degrees. Now the nice thing that I noticed about this one is that the pi's just canceled out, and all we had to end up doing was 180 divided by 3. Okay? So now let's look at my last example. So we have negative 17 pi over 9, and we're going to multiply that by 180 degrees over pi, and we're going to solve. Now I want you guys to do this one on your own, and so pause the video right here and try it on your own. So if you did this one correctly, you should have gotten negative 340 degrees. Now you are able to get negative degrees because all it means, instead of going counterclockwise, it is now going clockwise. Okay? So now let's look into degrees to radians. Now this is a similar process, it's just a little bit different. So when we have degrees to radians, it's like we have degrees. So this is what we're given, and we're going to multiply our degrees by pi over 180. So if you're probably thinking that looks similar, you're right. So these are being multiplied by a very similar number, or not number, but a similar fraction. It's just that it's flipped. Alright, so let's look at our first example. So we're given 40 degrees. So what we're going to do is we're going to take our 40 degrees and we're going to multiply it by pi over 180 degrees. So then when we do that, we get 40 pi over 180, but I want you guys to reduce this fraction. So when we reduce it, it's going to be 2 pi over 9, and then that would be my answer. Okay? So now let's move on to the next one. So we have negative 240 degrees. So we're going to take that negative 240 degrees, we're going to multiply it by pi over 180. So then now I want you guys to do this one. So pause the video right here and try it out for yourself. So if you did this one, you should have multiplied that negative 240 by the pi over 180. So you have negative 240 pi over 180. And then when you reduce that, you get negative 4 pi over 3. Now remember, I want that reduced fraction. I do not want that big number fraction. I always want the reduced fraction. Alright?